Hello and welcome back. In this video we are going to talk about some examples of higher order homogeneous equation with constant coefficient. So let's see. The first example we are going to discuss is this one. Say y triple prime, it means the third derivative, minus 7y double prime plus 9y prime 11y prime minus 5y equal to 0. So we want to solve the above ODE given that r equal to 1 is a root of characteristic equation. So one root is also already given. So we want to solve this ODE. So let's start. So first we are going to write down the characteristic equation. The characteristic equation in this case is, we replace the third derivative with r power 3, second derivative with r square plus 11r minus 5 equal to 0. Now we want to find out the roots of this equation, right? We know that r equal to 1 is a root. So since r equal to 1 is a root, r minus 1 is a factor of above characteristic equation. So what you are going to do is, you are going to divide the equation by r minus 1. You can use long division, and the quotient is going to be your factor. So if you will divide by using the long division, you will see that your quotient is going to be, let me check, r square minus 6r plus 5. This is going to be your quotient. Okay, so now we want to factorize this equation little more to find out the roots. Minus 6 can be written as minus 5 plus minus 5 minus 1. So r minus 5 and r minus 1 are two roots, two factors. So from here we got 1, 1 and 5. These are three factors, three roots of our characteristic equation. So the general solution to above homogeneous equation is given by c1 e power x plus c2, since 1 is repeating, so we will multiply it with x, plus c3 e power 5x. Or you can also rewrite as c1 c2x times e power x plus c3 e power 5x. This is our general solution. Okay, let's see one more example. So our next example is the fifth derivative, or you can write it plus 18y triple prime, means the third derivative, plus 81y prime equal to 0. And the problem is to solve this equation. We want to solve this equation. Okay, let's see. So first step is to write down the characteristic equation. The characteristic equation is r power 5 plus 18r cube plus 81r equal to 0. One thing readily we can see is we can pull out the r. So we have r power 4 plus 18r square plus 81 equal to 0, right? Okay, so one root is 0 for sure, and we want to find out 4 other roots. Okay, so if you look at this equation little carefully, what you will observe is you only have the even powers. So if we want to find out the roots of this equation, okay, so we want to find out the roots of this equation, r power 4 18r square plus 81. This equation is same as lambda square plus lambda r, plus 18 lambda, 18 lambda plus 81, where we replaced r square by lambda, right? And this lambda you can calculate using quadratic formula, or just by factorizing. So this can be easily factored. 18 is 9 times 9, so we will get lambda plus 9 square, right? So from here we have lambda equal to -3 and lambda equal to -3, these two roots. But lambda is equal to r square, so r square equal to -3 and r square equal to -3. If you take square root both sides, r equal to plus minus 3i, r equal to plus minus 3i. These are the roots. So let's collect all the roots. Roots of the characteristic equation are given by 0, plus minus 3i, plus minus 3i. So these are 5 roots of the characteristic equation, okay? And therefore the general solution of above equation, homogeneous equation, is given by yx, which is equal to c1 e power 0x is 1, so just c1 plus, now we are going to write down root corresponding to plus minus 3i, so it will be c2 cosine 3x plus c3 sine 3x. So this root is corresponding to plus minus 3i, but we have other root which is equal to plus minus 3i also. So that root we are going to multiply by x. X times c4 cosine 3x plus c5 sine, so sine 3x, so this should be 3x. And this is your solution. So this is how we solve our ODEs. We'll stop here today and practice more and more problems. Only practicing problems can help you to understand the concepts well. And take care. Bye bye.